The empirical rule is a rule which helps us make calculations when our data is normally distributed. So if my data is normally distributed like this, and we could say whatever the mean is, the standard deviation is, then there's rules that apply, but the data must be normally distributed to apply the rules I'm going to show you. What the rules in fact say is that if I know the mean and the standard deviation, and data is normally distributed, if I take the mean, whatever that value is there, and to it I'm going to add the standard deviation. I do the same thing on the other side. I take the mean, but this time I subtract the standard deviation. In this resulting range, according to the rule, you're going to see approximately 68% of the observations. So if I'm looking at students taking exams, 68% of the students' scores, that's what I'm looking at, will be between this point here and this point here. So let's just suppose we really do have students taking an exam and that the average score is say 75 and the standard deviation is 10 and the scores are normally distributed. This rule tells me that if I add one standard deviation, which is 10, to the mean, I'm going to get up to 85. And if I take away one standard deviation from the mean minus one standard deviation, so the mean minus 10, it's going to take me down to 65. So 75 minus 10 is 65. It says that 68% from over here of my students' scores will be between 65 and 85. So that's part one of the rule. There's actually 3 parts to it. The rule goes on and it says, look, if we have a normal distribution and you know the mean and standard deviations, and I take the mean and I add 2 times the standard deviation to take me slightly further out, so the mean plus 2 times the standard deviation, and over here it's going to be the mean minus 2 times the standard deviation, then this resulting range will have 95% of the observations, approximately 95% of the observations, this range in here. So if we apply it to our students taking the exam and we're looking at their exam scores, mean is 75, standard deviation is 10. So if I have the mean, which is 75, and add 2 times the standard deviation, 75 plus 20 is going to take me out to 95. And if I say the mean minus 2 standard deviations, the mean minus 2 standard deviation is going to take me down to 55. And according to this empirical rule, 95% of my students will get scores ranging from 55 to 95 in here. And the final part of the rule, the empirical rule says, look, if I have the same scenario, same setup, if I take the mean and add 3 standard deviations, and I take the mean and subtract 3 standard deviations, in this resulting range I'm going to get 99.7, approximately 99.7% of the observations. I think the PowerPoints actually say, I don't think, I know they say that's approximately 100%, but 99.7 is closer to the real figure. But 99.7 or 100% is fine. So what would it mean in terms of those students taking an exam? The scores are normally distributed, and the mean is 75, and the standard deviation is 10. So I'm going to get about 99.7, nearly 100% of the observations in the range that goes up to here. It's going to be the mean plus 3 standard deviations, which that would be 105. You can actually put down 105, but if your exam actually maxes out at 100, you may not want to push it up to 105. You need to be practical when you use stats. And the lower limit is going to be the mean minus 3 standard deviations, which is going to take me down to 45. So this is going to say, this is telling me that approximately 99.7, nearly 100% of my students will get a score in this range between 45 and 100 in this range in here. That's the empirical rule. Can't stress strongly enough, it only works when your data is normally distributed. So let's ask you a couple of questions. First question is, what percentage of students on this exam would have scored more than 95? So we can just look here. Well, this is more than 95. What proportion of students which would have scored more than 95? These students in here. And we're going to say, well, if this is 95 and it looks symmetrical, so there must be 5% left over, 5% over here and 5% over here. So this must be 2.5%. So the proportion of students, or the percentage of students that we expect to score more than 95 will be that value in there, 2.5%. Another question, what percentage of students would have scored less than 65? Well, less than 65 is this part of the empirical rule. These are the students in here. Now, given that if this is 100% of our students and 68% are in the middle, that leaves us 32% here and here. Between these two sides would be 32% jointly, which means there's going to be 16% approximately here. We'll be covering the normal distribution as we move on into the next chapter. Not the next video, but the next chapter. The last thing I'll point out for you here is that since you get approximately 100% of the observations between plus and minus 3 standard deviations, any values, any observations that fall out beyond this point or lower than this point are deemed to be unusual, and we're going to call those outliers. It's anything beyond plus 3 standard deviations, anything beyond plus 3 standard deviations over here, anything beyond 3 standard deviations or less than minus 3 standard deviations away from the mean is deemed to be an unusual, unexpected result, and we were going to call that an outlier. Get into here and call that an outlier. These green ones are outliers, unusual results, not expected. They're not the norm. Outliers, they do occur, they can occur, they often do occur, but they're unexpected results.